I guess we'll go ahead and get started now. It's 12:05, and so we'll let people just jump in while we're going through the presentation. So welcome everyone. My name is Tony Cockmo, president of the DFWBIUG Infrastructure User Group, and also president of Civil CAD Learning Solutions. So I want to thank everyone for joining the webinar. And our guest is Matt from Autodesk. Matt, if you'd like to introduce yourself and the presentation you'll be going over.
Yeah, absolutely. I'm actually going to jump off video just to reduce the resources here.
Okay.
Let me share my screen. All right. Move some stuff out of the way. All right, we'll go full presenter mode, make it look super professional, right?
All right.
So some of you may have caught this already before we officially kick this off, but this is actually one of the classes at AU. So you guys get to view this and, at the same time, free up that time slot to see something a little bit more interesting, probably. So, but yeah, so we're going to talk about point clouds and how we can sort of clean them up and make them a little bit more usable within some of the applications, and also talk about what are some of the new features with ReCAP and ReCAP Photo. So here's our agenda, intro, what's new, a little bit of a live demo. We're going to be kind of jumping back and forth between the software and the slide deck, and then we'll wrap it up with more slides. As much as I hate slides, I felt it was just much easier to convey some of the information here through the slides, but I apologize for the number of slides up front, and then we'll wrap it up with a Q&A. So my name is Matt Wunch. I'm a senior technical specialist with a focus on the AEC side at Autodesk. My former life, I was a CAD BIM technology manager for about 25 years. First touched Autodesk product way back in I want to say it was 90 or 91, and that was AutoCAD R10, and that had the, I'm using air quotes here, that 3D drawing of the space shuttle, if anyone has seen that. Throughout my career, I've done part-time tech support for Autodesk. If you've ever submitted a ticket, hopefully you haven't had to, but you may have seen me on the Directly platform. Also a former Autodesk Expert Elite. That title sort of gets stripped away when you become an official employee. So I throw in the former part there. I am also a Part 107 certified drone pilot, and I've got a little bit of a background with photogrammetry, reality capture, laser scanning, and hence the reason for this presentation. So what's new in ReCAP? Honestly, not a heck of a lot, but they are some really cool features though. So scan to mesh, you may have seen that one before. Basically being able to take that point cloud, upload it to your cloud project and create a mesh file from it. You can also publish, view, annotate, collaborate the 3D images. And I say 3D images, it's sort of the point cloud behind the scenes, but it's really that mirror ball, that 360 photo that's being uploaded that you'll see a little bit later on. And cloud storage has changed a little bit. We still have access to Autodesk Drive, and we have access to Autodesk Docs now, as well as BIM 360 for previous projects. Great thing about Docs and BIM 360 is it's unlimited storage. So if you've ever dealt with point clouds in the past, you know that these files can be ginormous. We're talking gigs and gigs worth of data. So whether it's your terrestrial laser scans or your aerial projects, your drone photogrammetry, all those photos, all the resulting data, the point cloud, the mesh, the geotiffs, all that information can be stored in the cloud. Again, unlimited access or unlimited storage, so makes it's super convenient to have all that information stored up there. ReCAP Photo. So we now have a 2,000 photo limit. That came out with I want to say the 22.1 release recently. So that previously it was 1,000 photos. Now it's 2,000. If your drone supports RTK, So for example, the DJI Phantom 4 RTK drone. Take advantage of that extra metadata within the files. Specify your ground control points with the local coordinate system. So basically being able to tie in all those photos, get a more, a tighter point cloud, tighter mesh, a lot more accuracy. Cloud credit consumption has changed a little bit. It's now 3 cloud credits for every 50 photos. Prior to that, there was sort of like a 3-tier break depending on where you sat within that 1,000 photo limit. So that has changed as well. ReCAP Pro, we can export those panoramic images of the scans. Being able to specify the units is huge, because prior to this update, every time you open up that project, it was automatically defaulting to metric, which we don't really do metric here in the States. So being able to set that to imperial units, just one extra or a couple extra clicks that you don't have to do once your project is processed. Behind the scenes, under the hood stuff, stability improvements, making your projects run smoother when it comes to indexing, importing, registering, and even creating scan regions, which we'll take a look at a little bit later as well. So, some nice improvements there to make the experience a little bit nicer, a little bit smoother. So, scan to mesh. So what exactly is it? Well, it's the ability to take part of that point cloud and upload it to your cloud project, be it Docs, BIM 360, or even Autodesk Drive. And it creates a mesh file for you. So you can create an OBJ or an RCM file. Cloud credit consumption, it's based on number of points, the quality that you choose, that high, medium, low resolution. And we'll take a look at this in just a little bit. But very simple process. The most time-consuming part of it, honestly, is cleaning up that point cloud. Defining just the points that you want to push to the cloud to create that mesh. Again, publishing and viewing those 3D images, so those mirror ball images. What's really cool about this is you can, once these images are uploaded to your cloud project, others can then start to annotate, do dimensions, and really start to get sort of that back and forth collaboration between accessing the cloud and the desktop version of that. And I'll walk you through this in a little bit as well. Cloud storage, again, Drive, Docs, BIM 360, you get that unlimited storage in Docs and BIM 360. So just keep all that data up in the cloud. All right, so enough of the slides for right now, right? Let's jump over to ReCAP Pro. Actually, before we get into this, really, I just wanted to point out when you install ReCAP Pro, ReCAP Photo is also installed at the same time. So it's not 2 separate installations, just that one file to download from your account management page, and that'll install ReCAP Pro as well as ReCAP Photo. So looking at that scan to mesh process, I mentioned the most time-consuming part is cleaning up this project, just to get the points that you want to export to the cloud, that you want to publish. Thankfully, I've already done that, and we'll actually take a look at some of this stuff, how we can go about doing this a little bit later. But I've got, my this happens to be like an outdoor utility substation type area. So I want to take this whole thing and I want to push it to the cloud. Very simple. Like I said, once you get it, once you get that point cloud cleaned up, just come on over here on the left, a little cloud. If you don't see this, it's possible that you're either not signed in, don't have a ReCAP entitlement, or potentially something with desktop connector. But you should see that little cloud and you should be able to push that start button once you're ready. So here we can define, once it finishes spinning in the air, so we can define our mesh name. What do we want to call this? I'll just leave it as, I'll call it plant site 2. Here I can select my cloud project, and it's actually defaulting to the desktop connector. So you just browse through this way. So any of the hubs that you're associated with, any of the projects in those hubs, you can drill down into those, find the project that you want to upload it to, which folder, etc. And we'll just say we'll drop it here. So again, mesh quality, low, medium, high. I'm going to bump it up to high. And which outputs do we want? Do we want that OBJ or do we want the RCM? Not a lot of options, fairly simple, fairly straightforward. Again, the hardest part is really just cleaning up the background of the point cloud here. It's going to show you how many cloud credits, in this case, whopping 1 cloud credit. So that's awesome. And your available cloud credits. And once you're ready, you just hit that submit and it's going to upload that file. I'm not going to do that just in the interest of time, and I don't want it to bog down the bandwidth here through the call, but it's really that simple. I mean, I hate to keep using the word simple and easy, but it really is. There's not a lot of options to choose from. So in other words, not really a lot to screw up, I guess, would be the easiest way of looking at it. So that's publishing or that scan to mesh process. So what does that look like once it's all done? Well, we've got recap photo. So I created that RCM file. And this is the resulting mesh from that. So depending on the number of points, the different settings that you choose, and of course the scanner, how dense are those points that are being captured. That's really going to determine the overall output. But taking a look at this, it looks pretty good. So this would save a ton of time versus having to model all of this up. If you were to take this and pull it into say InfraWorks, or I believe the 22.1 version of Revit just dropped, and I seem to recall there being an option for an OBJ file. So being able to import that OBJ file, if all you need is sort of that background context, it's a perfect example, perfect use case for generating all that content without actually having to model everything up in Revit, or throw this entire thing into InfraWorks in your site. Get a good view of what is already there on the site. So that is that point cloud with the mirror balls, and I specifically want to point out these mirror balls, right? So with all these individual scan locations. So this is where a tripod was set up, a scanner was placed, and the area was captured with that scanner. So having these mirror balls, that 360 color photo, is key to getting an output that looks like this. So we've got all the color on that mesh. Now, what happens if you go and fly a site? You've got a drone. Let's see if I can find my project really fast here. This should be it. Yeah, so you got a drone, you go and fly, you create this point cloud from all those photos, and you want to create a mesh of it. Now, this is probably not the greatest example because not a ton of color here, but here's what you're going to get. Because it is a drone flight, and that point cloud was created from those drone photos, that's considered an unstructured scan. So it doesn't have those individual scan locations. It's not creating those 360 mirror ball images. So when you do that scan to mesh using a drone flight, you're going to get this sort of gray clay model looking type of output. And again, that's because it doesn't have those 360 photos to basically attach to that point cloud. And again, I said this is kind of a bad example because it's, there's not a ton of color here, but you can see that there's some brown in the stones for the tower here, the different color roofing tiles, but you don't see any of that in this output. And that's because of that lack of the 360 scans or 360 photos to go along with the scans. Any questions at this point before we jump on to the next section here? Again, trying to keep this conversational. If anything pops up in your head, just feel free to shout it out. I see something in chat. What is that? Glad this is easy now. We have the metric setting. Yes, those metric settings. I can't, honestly, I can't tell you how many times that's screwed me up as well. Especially pulling in, say, a point cloud into InfraWorks and everything is off by a factor of 3 point, whatever the conversion factor is. Yeah, it's such a little thing, but it's such a huge thing at the same time, right? So just one less little pain point to have to deal with.
Is there a way to extract line work easily if you do need it from the scan?
So thinking like a 2-dimensional.
Yeah, like if you were doing an elevation view or something that's, old school.
Yes. And I've got a slide that'll show some of that. The slide is actually a plan view, but the same.
Sure, same concept.
Same workflow would work for an elevation. Yeah. Yep. Yeah, I'll get to that in just a bit. So that was scan to mesh. That was 2 different outputs that you get with, depending on the type of point cloud you're dealing with, whether it's the unstructured aerial flight scan or a structured, individually placed terrestrial laser scan type of data capture. Now let me jump over to this guy here. So this, you may have all seen this. This is one of those sample files that comes with ReCAP. It's this little like tech shop, a simple, if I zoom out here, we can't really see the mirror balls, but it's just a simple 2-scan area here. I'm gonna jump in. Let's actually go to this guy here. Now within ReCAP, so I'm back in ReCAP Pro, just to make that clear. This is not ReCAP Photo, but ReCAP Pro. Across the top here on the home icon, fly it out, you have an option to publish this point cloud to your cloud project. So I've already done this, but let's just kind of walk through some of the steps here. So you can see it says update because I've already pushed this to the cloud, and I can't actually change my location because, again, it knows exactly where it's living in my docs folder. But if you're doing this for the first time, you have the option to specify the project name and the location, just like we did earlier with the scan to mesh. Now you can also specify which scans to include. So if you've got a lot of scans and maybe you don't need all of them, you can certainly toggle on or off just the ones you need. And when you're all set, just hit that publish button and it's going to upload everything to your cloud project. It's going to use desktop connector to do all that, depending on the size of the project, number of scans, et cetera, the bandwidth and whatnot, that'll determine how quickly all that is complete. But once it's done, if we hop over to our cloud project, so I'm in Construction Cloud, I'm in my docs folder, drill down into where I have all of my published recap projects. And here's that sample project edits point cloud. So the same thing that we're seeing here, that edits point cloud. You're going to see a couple of files here, the JPEG, a PNG. What you want to click on is this RCP, and that is going to spin up that point cloud. Well, really, it's those 360 photos. But you can see the two different scan locations that I have here. We also have a little bit of a sort of the mini map overhead view. But what's really cool about this is we can really start to do some collaboration on these point clouds. So markup, viewing from, in this case, I'm in a Chrome browser, but I can add text, I can add dimensions, I can add any kind of annotations. So if I throw a note in here, maybe we need new wall paint. There we go, save. But you can see all these other annotations that I have here. I've got this, I got my dustpan tagged here. Actually, let me cancel out of that. Got my dustpan tagged here, and I've even included an image. This is the new dustpan that I want. I want this nice little blue plastic one instead of this old rusty metal one. We flip back over to our desktop version. We've got that same information. We can see that image. We can see that annotation, and this goes back, back and forth. Now, other note has not appeared yet. But if you see an instance where, the cloud notes, say cloud notes, so the notes that are done in the cloud project, if none of this happens to be showing up on the desktop side, and this actually happened to me earlier, you may have to go into your Autodesk Docs drive, drill down into your project, your folder, where is that particular project, and just force a sync, right? So it's going to download any of that information just to make sure everything shows up correctly. Again, in the event that something isn't automatically populating through the models here, or through the point clouds. But real simple, real easy way to get others involved in that process. So you don't have to have ReCAP installed on everyone's machine. You can just push this point cloud directly to the cloud, and share that link out based on their project permissions, etc. They'll be able to view or edit or add any kind of annotation to that point cloud. And again, that's reflected back on the desktop side as well. So great way to get both sides of this process involved now when it comes to point clouds. Alrighty, let's see, where's my, all right, I'm not gonna go into full presenter mode this time here. We'll do it this way. Point cloud, actually, yeah, we will, because I got a few animations here. So point cloud optimization, and we talked about cleaning up that point cloud earlier. What we're going to take a look at in just a bit is how we can do that using scan regions. So scan regions are a great way to break down that point cloud into, we'll call it bite-sized chunks or more manageable chunks of the overall point cloud. And depending on what you're planning on doing with that, you could ultimately create a smaller output, which again, if you've ever dealt with point clouds, that these things can be huge. So anything we can do to make these smaller, lighter, faster in AutoCAD, Civil 3D, InfraWorks, Revit, Inventor, you name it. Anything we can do, all the better for the end user. Unified point cloud decimation. This is probably my favorite tool in ReCAP Pro. And basically it allows you to specify a distance between points and kind of strips out any intermediate points. So, gives your point cloud a spacing, of 25 millimeters between points. So what this does is takes a file such as this one, which in total, 13 files, all those supporting subfolders, just over a gig in data. When we drop it down, we decimate it by, say, 25 millimeters and create that unified point cloud. It drastically reduces that file size down to 20 megs. The more you decimate it, the more you remove from that point cloud. Obviously, the smaller it's going to get, but at the same time, you're also losing a lot of that information. So what does that ultimately look like? Here's that same data set. So 1.2 gigs, undecimated. This just happens to be a simple, call it a scan, air quotes. Created this using an iPad, the iPad 12, and just walked back and forth, the front of my house here earlier this year, and just, kind of, air quotes, scan the front of my house. But this is no decimation, right? So it looks pretty good. A lot of detail. You can see, really everything there that the iPad captured. There it is at 25 millimeters. So still very good visual fidelity. Lost some points, obviously, because of the decimation process. But it dropped it down to 20 megs from just over a gig. 50 millimeters, really starting to get a little sketchy with, being able to easily identify corners of the house here, the overhang, the front door, the steps, and everything. And 90 is, it's pretty much useless, right? So kind of zipping back here, no decimation, 25, 50, 90. Personally, I've always found 25 to be that sweet spot between that visual fidelity, how much detail can you see versus the file size, right? So a 20 meg point cloud is it's gonna work much smoother, much faster in AutoCAD, Revit, etc., versus this heavy 1 gig, no decimation applied to it kind of point cloud. So I would recommend just kind of messing around with some of those that decimation output, and you'll see what works best for you, what works best for, based on the density of the overall point cloud, and how much do you want to see. So we're able, where can we use these point clouds, right? We can use them in Revit, we can use them in AutoCAD, Civil 3D, InfraWorks. Again, it's all based on, finding that sweet spot of the file size versus the information that you want to see. So here's these couple slides that I mentioned earlier. In AutoCAD, there's a tool. Once you select that point cloud, you have this option to extract lines from the point cloud. You can go through the settings here. The really cool thing about this command is, as long as you have this preview result toggled on, it's basically going to keep you in a loop within that program until you say, all right, this is what I want to accept. This is, this output looks really good to me. This is what I want to go with. So you have this ability to just kind of keep refining it based on the options that you choose here. And what you're going to get is something that looks, hopefully kind of good like this. You see these gaps here, and that's just because of, if I go back, that point cloud, it has gaps there, right? So if we have time, I can actually fire up AutoCAD and we can go through this, give you a better sense of what you're looking at. But really what this is just a slice of that same tech shop point cloud that we saw earlier. So, ideally you'd want to slice that point cloud in a location where maybe it's cutting through windows and doors, just so you have an idea of where those openings are. So you would, in that case, you would get some gaps here. So you'd have to fill it in. Maybe you've got a window block or a door block that you want to add into your drawing. It's a great way of easily and quickly generating all that line work with very little lift on your end. And just let this program do its thing. And again, you can run through this as many times as you want, modifying these options until you get something that you're satisfied with. And then you say, okay, yep, this is what I want to go with. And you'll get all those lines. And again, this can be done in an elevation view as well. So just a matter of how you slice that point cloud. Point clouds in InfraWorks, this is a much larger point cloud. Obviously, this is a flown with a plane aerial scan of a portion of New York. But being able to take that point cloud, process it, and create a surface from it, huge. And then in Civil 3D, you can take these point clouds. What are we looking at for time? Well, 1:30. All right. We may actually have some time to actually dig into some of this stuff. So in Civil 3D, you can go through and create your surface from the point cloud. So it's a great little tool. And actually, let me fire up Civil 3D. So that really kind of brings us towards the end. At this point, any questions, any comments about anything you've seen so far, anything you want to dig into? Like I said, I can fire up AutoCAD when you bring up that point cloud, that plan view, and take a look at how that is all.
Yeah, Matt, if you want to fire it up, I think we got some time. We actually had one of our clients ask me about that, maybe doing a comparison of when you're extracting some data on the InfraWorks from the point cloud. So maybe showing them how that works with pavement. I don't know if you have time to do something like that. A good example of data file.
I don't know if I have anything like that ready to go in InfraWorks. I will point out, though, that with the 22 release of InfraWorks, they sort of broke the the command to extract surfaces from the point cloud. So what you're going to have to do is run it as an administrator. Because if you don't, and this one I can actually show pretty easily, but it will fail, right? So you'll get a message saying can't process the point cloud. Let me actually.
Somebody asked is do the users have to have ReCAP installed to reference the point cloud in Civil 3D?
No. But I guess
you probably just need that LAS file or RCA file.
Yeah, that's sort of a loaded question. In AutoCAD, they unfortunately they removed the ability to reference the LAS, whatever other file formats they had at the time, but basically forcing you to process that point cloud in ReCAP, create that RCP or RCS file.
Yeah.
So in that case, you would have to have ReCAP to create those files, right? So we see the RCP, RCS. Unfortunately, it's out of my control. Don't shoot the messenger.
Yeah.
So what are we in? We are in
Civil.
Let's go to AutoCAD first. I got so much stuff open right now. Let's go to AutoCAD. We'll go. Let's build cropped. Should be my little plan view. There we go. All right. Once this finishes thinking. Come on. All right. So I have, where is it? I have this point cloud that is just walls only. So basically a stripped down version. Actually, I didn't show the scanned region thing yet. Kind of jumping all over the place now. But since we're here, let's finish out this, and we'll jump back to recap. But so this is just a slice of an overall point cloud. And if I can get my mouse to grab onto the grips here, right? So we can see there's more to it. This is the, the walls only of that little tech shop. Just gonna flip back, undo that. All right, so if we hop into a plan view and select that point cloud, right? So right here, section lines, this is where we can start to extract that data. I think this is remembering the last setting. So it's like super can, perfect output kind of type.
What units is that when you're putting in? Is that millimeters, like 1 or?
I believe it's just whatever the drawing units are.
Okay.
Yeah, not entirely sure. I haven't. It's the first time I ever got that question, so I'm not sure. Well, actually, I did a lot of cleanup on this point cloud too, to make it make it a nice data set, right? Like every other demo you see is a perfect data set, but they never really are, right? So we can see, based on some of those settings, we get these little chunks of lines, which is not ideal, right? Nobody wants to deal with, 1,000 little line segments. If we were to take a look at this, what do we, so, all right, so 32 polylines, right? Honestly, that's a pain in the ass to have to try to connect everything, right? Yeah. So let me undo that. All right, so go back in here, looks like it undid my settings as well. But I go in here and say create, and if I'm not happy with this output, I can come back in here and go back to settings. So settings is actually the default. So if I were just hit enter or space bar, it's going to kick me back into this command. So I can come back in here and start tweaking these things again. And, maybe I want to, I don't know what that's going to do. And what did I do? Oh, 110. We'll say 9, create. And yeah, it looks good. And then, at that point you say, all right, let's accept it, right? So now you've got your result, which is much better than the previous, so instead of having, 15 little polyline segments here, I now have just one that wraps around these 2 corners of the wall. But kind of going back, like I said, I deleted my point cloud. I really kind of tweaked this and cleaned it up quite a bit. But what you can do, to try to eliminate some of this point cloud noise, cropping, right? So I can come in here and I can do a crop on the point cloud. And I have the option of doing inside or outside. So sort of an inverted selection set. So if you've got these little points that may be showing up along the face of the wall here, maybe there's some, maybe some piping, or which actually there was in this, any of these points from the pipes, or whatever kind of tools or stuff that they have hanging on the walls, you can clean those up in AutoCAD using that point crop tool, and that's just going to make that end result much better. So take a little bit of time and maybe just do like a little window crossing and grab a bunch of points there, crop them out, save you a ton of time with regards to this whole fiddling around with the different tolerances here. So yeah, nice little tip there. And again, slicing this point cloud as well. Try to get a nice clean area of that point cloud. Depending on what you want to look at. If you want to crop it through the doors, the windows, etc. Up to you as to what you're looking for. But like I said, I totally skipped over the scan regions part, right? So yeah, let me turn off all my annotations here. Go. So, taking a look at this overall point cloud, we can easily start filtering out walls, floors, any of the sort of like vertical surfaces. And I'm actually going to delete all the regions that I have in here already. I'll leave that one. Just so you can see exactly, what's going on here. And delete the region. All right, pop this out. Keep it over here. So as we can see, so kind of looking up from the bottom, we can see this these series of points around this floor region, right? So I can turn it off, I can turn it on. But let's say we want to isolate, all the wall points. So how do we go about doing that? Well, we could do a selection fence or a window or something like that. If we change our view, turn off perspective. So when we're looking at it from the front or the back, everything's nice and straight, etc. You could certainly do that, but there's a much easier way. So I want to grab, all these points on this wall surface here. So I'm going to use the plane option here. And basically, all you do is just pick a few points on that plane. Hopefully, you don't inadvertently grabbing, you're not inadvertently grabbing a point that's back on some other plane. But if you do, it's easy to undo. So I'm just going to grab these points here. I can change the depth of this plane. So as it selects a slice of this point cloud based on this depth and this average of points. So there we go. So I've got this section here, and I can then take this and add it to a new region. So I'm going to call it walls. All right, so now I can see exactly these points that are associated with this region, and I can turn them off. And so I would go through and let's grab these points here. We'll do the same thing. We'll do plane, just pick a bunch of points and enter. And you can see I clearly grabbed something behind. If I create a new region, we'll just call this test. All right, so you can see how it's slicing now at an angle because I grabbed some point somewhere back here, probably through this area where it's less dense. All right, so we're just going to clear that, and we're going to redo, and we'll pick some points, a little bit more on this end, and hope that everything that looks better. Still showing the highlight of that little sliver for some reason. But let's just throw this on our walls section. Now, the other thing I want to point out, because we are using a depth of 50 millimeters here, you may have caught it and you may see it right now, but we've got a little slice running all the way through here, right? So that's based on that 50 millimeter depth of just from the points that we selected here, but it's grabbing them all the way across, right? So let's turn off all of these and turn on just our walls. All right, so we can see much easier now, all these points inside the room that, we don't really want associated with our wall points. I'm gonna turn off the mirror balls for a second here. There we go. So in a situation like this, what you can do is use a window or the fence selection tools here. I'm going to do window, and not being super neat about this, but we'll just grab all of these points, just like we did before where we associated them with the walls. Let's say we want them to be, unassigned. Right, so now they're part of this unassigned points group. So sort of the overall point cloud. But that helps clean up our wall section here, our wall scan region. So you would go through and clean up your point cloud doing a similar process. Once you get to a point where you want to start using it in Revit or AutoCAD, Inventor, what have you, this is where we start to get into the exporting, the decimation. So under export here, you want to create an RCS, typically, at least I do anyways. I like having that single point cloud. So think of it as taking an AutoCAD drawing with XREFs and binding them all into that host DWG file, basically doing the same thing with a unified point cloud. So I'm going to call this test 1. And this little gear here, it's not super obvious at first. If you happen to click on it by mistake, then you'll see this little fly out here. But this is where you specify your decimation. Right, so let's just, we'll say 25. We'll leave it at 25. If you can't get it just right on the slider, you can type it in, and then you define my scans. So it's basically, it's basically taking these, however many scan locations you have, those mirror balls. So in this case, we just have the 2, but it's taking just the scan or just the points that are visible. So totally disregarding anything else within this point cloud, and creating a single unified RCS file based on just these points here, and actually these little couple over here that are still floating around. But yeah, that's how you would go about, kind of cleaning up that scan file, making it a lot easier, a lot more lightweight when you start pulling it into other applications.
Real quick, Matt, I got a question. So
Sorry.
you're dealing with ground data and you're doing a decimation. Do you have a good recommendation number? You mentioned that other file you had, it was like 25 millimeters, but when you're doing ground data, is there a good number to use to try to, I guess, get rid of all the jagged contours? Any recommendation on that?
I think that one's probably going to be a trial and error type of thing.
Yeah.
I did want to show one nice little tip here. I don't know if this is it or not. Let's find out. Actually, 2 tips. InfraWorks. If your point cloud is not classified, so you take it in the Civil 3D, you click on the classification, and everything just shows up gray or unclassified, or whatever the. I think it just says unclassified, right? There we go. Yeah, this scan colors, classification. Oh, this one does work. Sweet. All right. So if it just shows up as everything's on my other monitor here. If everything just shows up as gray, it's unclassified. What you can do is you can take this same point cloud, you can run it through InfraWorks. And if I can just, there we go. So this is just a little like detention basin pond area here. So you can take that point cloud, pull it into InfraWorks, go through the process of creating a terrain from your point cloud. I would have it automatically create a new proposal. In this case, I've already got one here. But what I'd want to do is generate all points and all points. And what that's going to do is it's going to create a point cloud. I believe it's an RCS file. But based on however InfraWorks determines the object, those points in the point cloud to be buildings or high vegetation, low vegetation, ground, etc. It's going to create that classified point cloud for you that you can then take into Civil 3D. So you then get something like this that shows I've got buildings, I've got high, low, medium vegetation, I've got my ground points, so nice little tip there to get that unclassified point cloud into a classified version that you can then pull into Civil 3D. So talking about, creating a surface from the point cloud, right? So we can go through this process, do this thing here. We can kind of decimate it here a little bit, right? We can, if we tweak this value, we'll see this value change down here. There we go. So you can kind of go about it that way. Then you've got your options here. Do you want to do a planar average? Do you want to do interpolation? Do you want to do no filter? I would honestly, because we have a classified point cloud, I would say we don't want to do any of this, right? We want to step back and fire up our map space here. And we want to add point cloud data from our point cloud. And it's down here. So this is my point cloud that I brought in. I'm gonna say okay. And there we go. All right, so what I want to do now is I want to further filter this data, right? So come in here, filter, and let's see, I want just the ground, right? So I just turned off all the other points. So now I can come in here and I can create my surface from the point cloud. And when I do this, you can do straight up no filter, right? Because it's just creating a surface from just the ground points. So rather than having to mess around with any interpolation because of trees and cars and other stuff that you see in that point cloud, just filter out everything but the ground plane, do a straight up no filter, and that's going to give you the most accurate representation of that point cloud. So a little bit of a couple steps there to get to that point. But great way of, come on, ground, filter. Why is it not showing up here?
Does it allow you to select 2 or 3 options right there in that menu? Classifications.
I believe so. Let me just
delete
what's going on here. Filter.
If I remember right, I think you can. It's been a while since
clear the filter, right? Clear. Why is my filter not clearing here? Let's just undo a bit here. I don't know if I've just got a regen problem going on here, but that seems to be the case because it's not,
that's what it looks like.
It's not kicking it back to what it was before.
Does anybody have questions so far? Additional questions?
I guess as far as creating the surface, do you recommend going from ReCAP through InfraWorks or just attaching it this way?
If it's not classified, I would probably kick it through InfraWorks just to get that classified point cloud. Otherwise you have to
do it some other way.
Yeah, or just deal with one of these options here.
Yeah,
I certainly wouldn't go no filter if I'm showing all the trees and the buildings and everything, because that's gonna, that's clearly not what the ground looks like. And likewise with these, it's taken that average or interpolation between the points, and that's inaccurate as well. So anything you can do to get it as accurate as possible, I would certainly recommend that. If you're downloading the point cloud from a town or state website, agency, something like that, chances are those are going to be classified already, as is the case with this one from Pennsylvania. They've got this whole database of information that GIS info that you can download, one of which is point clouds, and it's all classified LAS files. I just had to run this through ReCAP to get it to be an RCP or an RCS, so I could actually pull it into Civil 3D.
Yep.
But when you do that, it retains that classification, which is great. But yeah, if you don't have the classified point cloud, I would probably kick it through InfraWorks. And I don't recall if we talked about this prior to actually starting, but in the 22 version of InfraWorks, they kind of went backwards a little bit and broke the terrain point cloud terrain command here. So in order to get it to actually process correctly, what you have to do is run it with elevated permissions. So basically just run it as an admin, and it's going to fire up InfraWorks as it looks normally. But for whatever reason, it just needs that little bit of elevated permissions to run through that processing. And I believe, don't quote me on it, but I want to say it's been fixed in the 22.1 release, which I think is supposed to be coming out very soon. But I know Ramesh does know about this. I've actually pinged him a number of times on it. But so that is the workaround if you happen to see a failure to process the point cloud. But yeah, I mean, I would try to create those classified point clouds. I don't know if I have any handy at the moment.
Would it make sense to, at this point here in InfraWorks, just to go ahead and build a surface and then link the surface to Civil 3D and let it bring in it as a surface?
That's certainly another option.
So now it comes in as a Civil 3D surface. That is creating another point cloud and then bringing it back into Civil 3D as a point cloud, where you can probably just make it create a surface and then bring it in Civil 3D with that import Civil 3D option, import from InfraWorks option, and now you have a surface.
True, but it's also, keep in mind it's based on that USGS data, so it's super rolling interpolated terrain. You're not going to get those sharp breaks with retaining walls and roadways and the like. But yeah, definitely, if you're at the beginning of a project and you don't even let's say you don't even have the project yet. So you're just going out after it. You're trying to collect some of that data. Whether it's through a drone flight or just straight up model builder. Yeah, definitely a great way.
I know, like, if you're in Texas, you can get a lot of that Texas point cloud data from the TNRIS, Texas Natural Resource Information System website. And I think you can buy all of Texas for maybe $100 or something. That's what I used to use way back in the day for pre-development, site planning and using that point cloud data.
Yes, as far as keeping a Civil 3D manageable size drawing, do you just recommend like splitting up your scans, or how do you go about doing that? Do you just kind of limit your scan data to a certain area?
Yeah, definitely when it comes to like this workflow of pulling in the InfraWorks model. Right, so I'm just going to set my coordinate system here. So I would typically just select an area of interest. So my entire InfraWorks model, is showing this for the limits, which I'll typically make them oversized just so when you start looking at it from different angles, it doesn't look like you're like looking off the edge of the world, if you will. You've got some nice context in the background. So this is that same file that I just started to bring into Civil 3D here. Close AutoCAD and try to free up some resources here. All right, so I've got this huge chunk of a model here. But my project site is really just like this little bit over here. Again, in InfraWorks, I'll create that oversized model just to have more of a background, if you will, when it comes to looking at it from different angles, and especially when you're doing videos and fly-throughs. You don't really want it just limited to this little area here. But in Civil 3D, if that's the project area, absolutely, I'm just gonna everything's just crawling here. Don't save. Don't save. All right, where's my? There we go. All right, so my area is over here somewhere. There it is. All right, so I would just bring in, say just this little area here instead of the entire thing. So that's obvious, right off the bat, that's obviously going to make your file smaller, not having to pull in all that information. You can also set, kind of preset some, call them selection sets, if you will. If you don't want to bring in some of this information, that's obviously going to make it more lightweight as well. The less info you have in there, the smaller the file will be, more manageable it'll be. But the great part about this is, you can easily map these to all your company standards. Where did it go? It's on another monitor. There we go. All right, so you can have your company standard set up and just have it preset to automatically pick contours 2 and 10, or I don't want to bring in water areas, or I don't want to bring in whatever the case may be. Once you have that selection set, just open up that model and what's going on here. Oops, it escaped one too many times. All right, let's jump back into everything's on the other monitor. Is it going to let me do it because I have the model open? I don't think it will. So that's another good point. If you have that InfraWorks model open and you try to do this process in Civil 3D, it's gonna basically yell at you and say, close that model, without actually telling you to close the model. There we go. Go through this. Go through all this again. All right. Coordinate system is set. Area of interest. Kicks me way back out. Go. Now, the cool thing about doing this, pulling this information into Civil 3D, if your InfraWorks model has component roads, those component roads are going to come across as your alignments, your sub-assemblies that make up those component roads, as well as the corridors. And you'll see that in just a second once this runs through here. Those sub-assemblies will be sitting down here somewhere below. All right, there you can kind of see them at the moment. So as it processes everything. All right, so having those component roads could be a huge time saver when it comes to creating, or in this case, not having to create those assemblies and those corridors, because it automatically pulls them across as those types of objects. Any other of the planning roads, those will just come across as just straight up alignments. You do get all that intelligence, so you know, it knows what the road names are, all the information associated with it. So this could certainly be a quick and easy way to get a surface into Civil 3D. And everything's on the other monitor. There we go. All right, so this is one that I actually modified a little bit so that middle school is over here. The playing fields, the ball fields are down here a little bit, so a little bit of a drop in grade there. But yeah, like I said, if you're just going after a project, you don't actually have it yet, huge time saver, right? When it comes to collecting data and actually getting something usable in Civil 3D. Just using that model builder feature, which I guess we'll just touch on that real quick. So if you've never used model builder before, basically a map interface. In this case, it's all built on Bing maps. Typical map maneuvering, left mouse button to pan, the scroll wheel to zoom in or out. If you know the exact location, you can type that in. Brings you right to that area. There's that middle school again. Specify your coordinate system. I have it in my recent list here, so I'm just going to drop that in there. And we'll call it DFWBIUG, right? There we go. You can do the entire extent of this viewport. You can specify a rectangular area of interest. You can do a polygon. You can also import a shape file. So maybe it's like a neighborhood or city block, or if you have that outline, you can pull that in. The key thing to remember here is, as I zoom out, my area of interest cannot be larger than 200 square kilometers. If you run into a situation where you need more than that, there are some workarounds to sort of combine models, basically exporting to IMX and then pulling everything together. Kind of a pain in the neck, but it can be done. But if at all possible, try to keep them below 200 square kilometers. And
yeah, I was more curious just to see if the through ReCAP and the InfraWorks workflow, if there was anything other than the classification, but there's 3 different ways to do everything, right, as far as getting a surface. So just the best way. Exactly.
And this model here that I'm opening now, I've actually manipulated it a little bit, as you saw in Civil 3D. If we take a look at the different surfaces here, we've got the existing ground and existing transportation. Those 2 are just InfraWorks defaults. This proposed one, this is the one that I've modified a little bit in InfraWorks using grading objects, so kind of making it a little bit more realistic. Because if we take a look at this area here in the master proposal, so hasn't been touched before. That's just what InfraWorks gives you based on that USGS data. There's like a 90-foot difference between home plate and like first base on this ball field here. Clearly the baseball field is not on a hill like this, right? So if we take a look at the elevation here, so home plate is at 96. All right, so like 30 feet. So we're up at like 120 at first base. So it's a nice little workout there, running from home to first on your first at bat there. So modifying some of this with the grading objects, all that information, all those changes get pulled across into the Civil 3D when you pull in that information. So just a
Which
couple
one
quick.
do you think is a better process, taking it from ReCAP to Civil 3D or taking it from ReCAP to InfraWorks then back to Civil 3D?
I guess it would depend on if that point cloud is classified to begin with. You know,
Yeah.
if it's unclassified, I would probably kick it through InfraWorks, you know, just let it churn in the background while I'm working on something else. And then when it's done.
But if it's classified and they've done it through like Trimble or whatever certain software they're using, or whatever point cloud software they're using, or Pix4D, then we just take it straight to Civil. Right.
Oh, well, possibly. I mean, you probably have to run it through ReCAP to convert it from LAS or PTS or whatever whatever it is to get it to that RCS or RCP format, which is, you know, again, don't shoot the messenger. I wish we had those other options still.
Yeah.
But yeah, unfortunately, you're probably gonna have to run it through ReCAP just to get it to that format that Civil can read.
Yeah. Cool.
But yeah, I mean, like you said, there's
go ahead.
There's a number of ways to do things depending on what we're looking at.
Yeah,
here.
depending what data you have and what sources and what's all been done with it too.
Exactly.
Well, cool.
When importing the data, is there any unit transformation you have to be aware of when bringing in like an LAS into ReCAP to get that RCX or RCP, excuse me?
Hopefully, if it's already in imperial units, you should be fine. I mean, it's I haven't come across an issue where something was captured in metric, you know, just because of, you know, that's not typically what we do in the States. So I haven't personally run into that, but I mean, I guess it is possible, right? So you'd have to.
Well, what I mean is whatever units my point cloud are in, when it gets converted to an RCP, is there, like I've been running into US survey feet versus imperial feet units that have been in and out of Bentley or in and out of Civil. And I've got to be very careful about the storage units of the drawing or where they came out of, or we'll see these. Well, in our type of the world, it's about 15-foot difference.
Let me crack open.
If using like a large coordinate system, like a state plane.
Sure. Let me crack open. Let's see, this should be Connecticut. Yes.
Yeah, I don't think I saw any other options in here.
Yeah,
In your like your coordinate systems, what choices do you have up in that coordinate system? Usually there's like a search or some EPSG codes. Okay.
I don't
Looks like you
see.
can sort by EPSG, so that's something.
Yeah, I don't see anything that says specifically, you know, survey feet.
Survey feet. Okay. We'll just have to test and see which one. I'm sure it's probably imperial feet.
Yeah, but I guess something to definitely be aware of, though, right?
Yeah, because those EPSG numbers, those coordinate systems, by definition, some of them are in US survey feet. So they say I'm using a coordinate system that's in US survey feet, and here my project units are in imperial feet. That's where I have to test it to see what the program believes is who wins, the coordinate system or the project units.
It's a good question.
Tell me about it.
So that's all I've got. Let's see, we're about 20 minutes over, which is fine. I got a couple minutes to my next.
Yeah. Anybody
meeting.
any additional questions? All good questions so far. Matt, if somebody wanted to reach out to you, you want to post your contact info?
No.
No.
Do I have it on here? I don't have it on here. Now let me just throw it in the chat.
Okay. Yeah.
No, why is it defaulting to you only, everyone? There we go.
There you go. Yeah, if you have any additional questions, you know, you can email Matt. You can also reach out to Matt. Open, so. Matt, did you see the post on the Q&A?
I think
Oh, it might be
I
the same
just-
question.
Extractions. I have to constantly think about coordinates.
I think that was the same question.
Yeah, that was the same question.
Yeah,
posted by-
yeah. Okay. And we might run some tests in there, Matt, I don't know, on that from US survey foot to imperial foot.
I saw this on a Bentley product as well, where I'm like, you don't get to usually specify the units of a coordinate system. The code is because of the units, or certainly a part of it. So that's where I run into these problems with different software platforms that who wins, the coordinate system or the storage units of the drawing. You know, you set it in the coordinate system, and then you pick a different unit for the storage units, maybe. For me, I set checkpoints and throw them back through TBC every once in a while to make sure everybody's still in line or Trimble.
Yeah.
Excellent.
All right. Well, I want to thank everyone that stuck around and watched the end part of our webinar here, and definitely, you know, write down Matt's email address if you have additional questions about ReCAP and even InfoWorks and stuff. So hopefully next month we'll maybe do a session about InfoWorks and Civil 3D, and then with point clouds, going back and forth between that data, GIS data, and InfoWorks. So, we did record it, so I'll post it on YouTube, this video, through the CivilCAD LS YouTube channel on YouTube. So be sure to follow us, and we'll post it on there probably by next week. I'll post this video on there. So, all right. Any last minute questions? All right. Well, thank you, everybody, and I hope everyone has a great day. And I will talk to you later. Thanks.
Thanks, everyone.